Hello, ladies and gentlemen. What a snowy day it was today. I didn't feel well at all. I was not in school, as you already know. Um, so, welcome to the Completing the Square screencast being brought to you directly from my dining room table. So, before we get into discussing completing the square, let's take a look at factoring some trinomials out of perfect square trinomials. So, why don't you pause this and factor those two. You have x squared plus 6x plus 9 and x squared minus 16x plus 64. So pause this for a minute, factor those, then come back to this. So when we look at how they factor, the one on the left is x squared plus 6x plus 9. That factors to x plus 3 times x plus 3. And the one on the right, x squared minus 16x plus 64, factors to x minus 8 times x minus 8, or in this case, x plus 3 squared, or this one, x minus 8 squared. Those are called perfect square trinomials. Now take a minute and briefly look at what the factor here. Really only one factor. It's x plus 3. Look at the 3 and then look at the trinomial here. Look at the negative 8 here and look at that trinomial there. Because completing the square requires that we be able to make the connection between our factors, x plus 3 times x plus 3 in this case, and what our original trinomial was. And the same thing here. So I believe you covered completing the square previously. So when we look at this, and we'll start out with something like this, x squared plus 8x minus 4 equals 0. That is not factorable. The thing that stops it from being factorable is the minus 4. That's the c term. Okay, if we look at a quadratic, a is the term in front of the x squared. In this case, it's 1. The b term is the term in front of the x, which is just 8. And the c term, in this case, negative 4, is a constant. So it's the c term that stops us from factoring this quadratic trinomial. The first thing we do is we get rid of the c term. You move it to the other side. So in this case, we added 4 to both sides. Then we've got to create a perfect square trinomial. So we have to force this into a situation that we can factor. So, and remember, whatever we add or subtract on the left, we have to do on the right as well. That's why there's these two open boxes here. So, to find what we need to make this factorable, you take the b term, the 8, coefficient, the middle term, or the x term, the b term also. You take half of it. So 8 divided by 2 is 4. Then you square it. 4 squared is 16. You can add 16 to both sides. So take half of the middle term, square it, and that's what you add to both sides of this equation. So again, 8 divided by 2 is 4. 4 squared is 16. So completing the square, since we have x squared plus 8x plus 16 on the left, that factors to x plus 4 times x plus 4, or x plus 4 squared, equals 20. Okay, so let's go through this again. The thing that stops us from factoring this quadratic is the c term. So you move the c term to the other side. In this case, we add 4 to both sides. So that's fine. Then you take the middle term, the b term, and you divide it by 2. 8 divided by 2 is 4. You square it. 4 squared is 16. You add 16 to both sides. Now the left side is a perfect square trinomial. In this case, it's x plus 4 times x plus 4. And the right side, 4 plus 16 is 20. So now this is factorable. So, pause the screencast. There are two practice problems here. Write the first one down. X squared plus 6x plus 1. Remember the steps. It's the one that's stopping us from being able to factor this. So you subtract 1 from both sides. Now you guys completing the square. Oh, that sounds odd. Complete the completing the square. All right, so finish this up. Pause the screencast, follow the steps, and then when you come back, we'll go through the solution. Okay, welcome back. So since the 1 is what stops us from factoring this, we subtract 1 from both sides. You have x squared plus 6x equals negative 1. Then we take the 6 and divide by 2, is 3. 3 times 3 is 9, so you add 9 to both sides. So we wind up on the left as x squared plus 6x plus 9 equals negative 1 plus 9 is 8. The left side factors to x plus 3 times x plus 3, or x plus 3 squared. That equals 8. Let's take a look at this second problem. 2x squared plus 20 equals 6x. Now there was one little note on the steps for completing the square, and that comes into play here. I didn't mention it then. The x squared term cannot have anything other than a 1 in front of it. So we're looking at this 2x squared plus 20 equals 6x. There's a 2 in front of the x squared. You have to divide that out of everything. So do that. You'll have to move the terms around and close the screencast, and when you come back, we'll go through the solution. Okay, let's take a look. What I did first is I moved the 6x to the left, and I moved the 20 to the right, and that's where I'm at. So then I divide everything by 2. So 2x squared divided by 2 is just x squared. Negative 6 divided by 2 is negative 3. Negative 20 divided by 2 is negative 10. So then what do? We take the negative 3, divide by 2. That's 1.5, 1.5. And you square that. 1.5 times 1.5 is 2 1/4, 2.25. So you add 2.25 to both sides. So the left side of our equation is x squared minus 3x plus 2.25 equals, on the right side, negative 7.75. The left side will be a perfect square trinomial, and it's x minus 1.5 times x minus 1.5 equals negative 7.75. Now, if you look at this one, we have x minus 1.5. If you look at the previous problem, our factor was x plus 3. How do you know what sign goes in here? If you look at this, that's a minus the middle term. You need to have a minus in the parentheses. So you have the square root of the first term, x squared, square root is x. The square root of 2.25, which is 1.5. And you're going to drag the sign from the middle term. So that's how you know what sign, whether it's plus or minus, goes in your parentheses. So if you need to go back over the screencast again, do that. We're going to be going over this in class. And thank you for tuning in to the latest edition of Math 12-Hour Screencasts. And this was the screencast for completing the square.